Hi all, welcome back. Today I'm going to give an update. Yesterday I made a video describing the first week of my, or mostly first week of my sort of novel AI training experiment. Actually, it was a week. I think it was 5 days of training runs, but that was only the last 5 days because before that I had a few runs that I started and then abandoned. So for a week I've been working on taking Doom roguelike, which is a simplified sort of roguelike based on Doom. It's a bit simpler than NetHack. You could arguably say it's a bit more complex than Doom, but it's a roguelike that's relatively easy to learn. And I thought it would be fun to do a project at home in my spare time to figure out if it was possible to train a convolutional neural network, a CNN, to play this game reasonably well. I have a secret long-term plan to even see if I can get a more long-term thinking model to effectively eventually look at the replays from the CNN and learn how to play more. So basically the CNN right now is gathering training data and making replay videos that I can replay into the other one ideally. But in the meantime, it's fun to give these little training updates. And so as you might remember, if you watched yesterday's video, yesterday after 5 days of tuning variables and restarting the engine every once in a while and then letting it run for 5 days, it cleared level 1 for the very first time. And that was, of course, for me, a massive, massive, massive feeling of success. Of course, it's clearing level 1 on the easiest difficulty, and I was clearing level 1, the exact same level 1 every time because I had fixed the random number seed at a given starting value. So it was generating the exact same level, unlike the real game where the level changes. So that's what it was doing up until yesterday, and then yesterday it first finished the level, and I showed you the replay if you look at yesterday's video. Right now, what I'm going to do is I'm going to walk you a little bit through the training variables. One thing you have to keep in mind, and this is really kind of mind-blowing, right? For every single frame, for every thing that the AI does, the setup works like this. There is this wrapper around the entire game. We've ripped apart the UI from the engine and we've put an API in the middle so that we can have a program so that we can get information out of the game engine and we can give our model the ability to pretend to interact with the keyboard and mash buttons and then see how the game reacts. The AI model actually sees basically the visual representation of the game, although not exactly the way we would, but it sees basically sort of a unique barcode for every single kind of character or thing that might be showing at a given screen coordinate, just like we do. So over time, it can learn how to pick out text strings just by recognizing that they're the same pattern. It can learn to pick out what's an enemy. It can learn to pick out what's a door. It can learn to pick out what's a wall, a tree, whether it can walk through it or not. Whether something could be potentially loot that it can pick up. It has the visual information to gradually figure that out, but it's like a baby, right? It's never interacted with this world at all, and it's never interacted with this keyboard at all. This is all just a way for it to provide a lot of different inputs and then get some rewards. So along with that visual, which means nothing to it, it gets back a single number after every single turn, every single time it hits a button. The game state advances by something. It could advance by nothing. It could open a menu. It could actually spend a game turn and stuff could happen, like a monster could shoot at it. And then we also observe the game state. We have a bunch of code here that actually scans the display as well for text strings to show up that might tell us what just happened in the game or whether the agent, the bot, the machine learning model. You'll see me. My favorite thing to call this model right now is just Doom Guy. So what Doom Guy did and whether it was good or bad, we also tried to learn that, and we've done a bunch of things like we read these text strings from the display, and we get some numbers out of the game engine, like the current level of experience of the character, the current health points of the character, whether the character has inflicted damage on an enemy recently, whether an enemy has been killed recently, Those are all things that we can detect turn by turn, and we can also detect from the messages things like whether you probably opened a door or not. And we can detect things like, did you just discover a door? Like, did a door just show up on screen? Did some loot just show up on screen? Did you just discover some squares that you haven't been to before? We know the player's position, so we can see if he's standing in one place or if he's moving, by whether the coordinates are changing. Those are things that we can see. And then we can add a bunch of rewards, but at the end of trying to evaluate the entire game set, we give you back one number. And that gets complicated. So let me walk you through this real quick so you can see what kind of complexity we're dealing with. We have some very, very basic rewards that, are basically like the game's milestones, right? And what you can see though is some of them are now set to 0. And the reason for that is that we are now actually rewarding damage dealt. So if we're rewarding damage dealt, we don't necessarily have to reward a kill specially anymore. As long as you've dealt damage and then you're safe, you should be able to figure out at some point that killing the enemy is necessary and good. We give you a reward for dealing damage. That's pretty significant. And these are factors. So basically, we now query the engine. This is why some of these strings, we used to do all of this based on these strings. But now, and when I say we, it's just me and this, it's me and like Google's anti-gravity IDE and Gemini Code Assist. So, right. So we have decided, by the way, what I can say, this I will take credit for. I don't take credit for any of the code changes here, because I basically just say, hey, I think we need this. And that's very difficult because this program was written in Pascal, and AIs suck at Pascal because there's not much of it. And so every time that Gemini Code Assist tries to change the Pascal code, and I'm not criticizing it at all, but every time it tries to change the Pascal code, it makes compiler errors, and I do have to go back in and make sure that I understand how I can make sure that the thing actually works. So then I have to make it, print more debug messages and stuff like that until I'm confident that it actually did anything. But then the Python wrappers around this that set up and start the training and manage the training for this convolutional neural network, the CNN, that stuff I can kind of trust, because there's a lot of precedents. There's tons of Python code. It's very good at that. So there, I pretty much have to say, hey, let's change this, and except for every once in a while, because like when I do a refactor, it usually works. That was a bit of a tangent. What I'm getting at is that I don't take credit for the code. Code just happens in the new world of AI sessions, but I do take credit for thinking of every single one of these variables, because this is basically coming from me watching replays and figuring out how to reward or penalize different things that I see, and sort of micromanaging this model on this very primitive, very slow running setup where it's only running in a single thread on a 5-year-old laptop, maybe using on the order of 5 watts at any given point in time to learn. So I'm very much micromanaging and hand-holding the very early training. And then as it goes on, it just has to run for longer, like to really start developing its own understanding and strategies. That's going to have to take a very long time. Or I may at some point run in parallel. Oh, for those of you who are super nerds and who are wondering why I'm not using the whole graphics card and why I'm running in a single process, that is because this game is in Pascal. And there are times where it does things like when you open a certain screen in the game, it actually opens a file and then renders that file and keeps that file open. And so when I was setting it up to run in multiple processes in parallel, I was trying to get it like to 8 processes and do more work, and I might have gone further. It got into long delays, and the reason it got into long delays is because like one agent, one Doom guy in one process would get to a point where he thumbs it on in the menu and opens this file, and then another process, the Doom guy just happened to be fumbling around until it opens this file, and then it can't open the file until the other one exits. So I don't have twice as much training. What I have processes blocking each other to try to read the same files, and the operating system saying you can't do that. And then just long stutters and stalls where these things are actually locking each other up. So in this particular case, until I also maybe rewrite this whole thing in C or C++, at which point the original authors would probably get mad at me, I'm just going to run it in a single process for a very long time. And that's going to give me a chance to have very detailed insights into the good news. The good thing about this is I now get to have very detailed insight into what is working and what is not. So basically, when I look at it a day later, which is about all the time I will have during the work week, I see something that maybe on an actual like data center scale, learning setup, somebody would have had to look like a minute later to notice it, right? So the nice thing there is I can actually build what would be called pathological feedback loops into this thing, and when it starts to learn them, I realize it within a day and I change them. And it means that like, for example, suppose that I try to reward the bot, the Doom guy, for learning how to pick up a weapon off the ground. And I say, okay, you picked up a weapon. I see that message. You get some points. It could now learn, if I'm not very careful, that if it drops that weapon and picks it up again, it gets more points. And if it drops that weapon and picks it up again, it gets more points. And I could be looking at a very, very complex, very powerful setup a day later, and the only thing that agent now has burned into its memory is that it just farms points by dropping the same weapon and picking it up over and over again. I don't have to worry about that so much because the amount of time it would take to burn in that kind of behavior is much, much longer. Like I might see a little bit of that kind of thing starting to burn in after a day, and then I can tweak my reward structure and make sure that that loop is eliminated for a while, and then I can watch that smooth out relatively quickly. That was quite the digression. So let's walk through the rewards and penalties I've come up with here. The most obvious ones are, you deal damage, you gain experience and level up, you heal yourself, and you deal damage, and you take damage, right? So taking damage is bad, healing yourself is good, getting XP is good, and killing is good, right? So why does kill have a 0.0 multiplier? Because he has figured out how to kill. And now what I'm trying to focus on is I'm trying to focus on damage specifically because I'm trying to see for the very first time, I want to see him successfully pick up the shotgun off the ground and realize that it's better than a pistol, right? And that means that I've switched from just saying, before I had messages like you hit something and you get some points. I turned that down to 0 points and then commented it out. And now instead I say, I actually figured out from the game engine how much damage did you do, and I give you points based on the damage that you did. And because the damage numbers are big, this looks like a small factor, but it's actually quite a bit. So you take damage, that's bad. You do damage, that's good. You gain experience, that's good. You heal, that's good. Another thing I can say, by the way, in case you ever try to do this at home, when I started, you have a model that is just mashing the keyboard. And I think I showed yesterday at the beginning of the video what it actually looked like in the first replay when all the model was doing for like a few minutes is just bouncing in and out of different screens. And so we started penalizing it very heavily for being in menus to relatively quickly teach it which buttons hurt. And now those kinds of now these rewards are much more subtle. We're making much more smaller changes because it turns out that there's a thing called entropy loss. And in order for the model to start to converge on sort of understanding and following specific behaviors, you actually don't want your penalties and rewards to be massive. You want them to be within sort of a couple of orders of magnitude at most, so that you're not just blowing the statistics out of the water. And so the smallest kind of penalty that the models tend to understand is around 0.01. And then anything above a 1 is pretty damn big. And we only use that for edge cases, for very rare behaviors that we still want to reinforce until they become more frequent, or things that we really want to punish until they become very rare, very early on. So the next thing we have after these basic rewards, we have magnets. Magnets are the concept that when a certain kind of thing shows up on screen, you should generally go there. We do that by saying you get some number of points when you go there, when you go towards it, and you lose the same number of points or more when you go back away from it. The difference there is whether the magnet is symmetrical. You get, say, 0.05 points for approaching the door, and you lose 0.05 points for walking away from the door. Or whether they are asymmetrical, this stairs magnet, you gain 0.5 points for walking towards the stairs to the next level. You lose, say, 0.6 points for walking away. So that's an asymmetrical one, means you lose more for walking away than you gain for walking there, and that prevents wobbling. Because wobbling basically means it figures out that it just gets 0 points, and it makes no difference if it just goes back and forth, towards the stairs, back, towards the stairs, back. Then it might just do that. So then we have navigational events. These are basically teaching it to traverse the level. So saying you get initially still a lot of points for breaching a door, for first going through a door. This is about to come down. You get a massive reward still for getting to the stairs, and that's because it's happened very rarely relative to the amount of total turns the bot has taken, that the agent has taken. Doom guy, sorry. And you still get a very, very, very big reward for actually hitting the spacebar. And that's because in most circumstances, normally on the map, the spacebar is bad. If you hit the spacebar, at best, you are wasting a turn most of the time, which means if there's an enemy near you and you hit the spacebar, you do nothing and you get shot. So there's a lot of reinforcement that happens that the spacebar is bad, that we then have to really make sure it actually understands over time that in this particular case, when you're standing on the stairs, the spacebar is good. Okay, so then we have different penalties that are, aside from the health up here, these were basically to teach it to move. So one thing is there's a general penalty for every turn. I think this is one of the ones that the agent that the AI session did come up with, is to say, hey, look, usually what you do is that, if you want to teach it how to make progress, then you take away a tiny bit of points anytime it just stands there. And then when we saw it then we saw it making progress, but it would like walk across the map and then stand in the corner. And so we added other benefits we started with this one I came up with. I like it, worked really well. It's basically giving it hot feet. So saying that when you stand on a tile the first time, it burns you for 0.1 points that you lose for standing on it. Then every single time you step on the same tile again, or that I catch you standing on the same tile a turn later, you lose 0.1 times the number of times you've been on that tile. And that we keep track of that for the entire level. So basically the entire level, it always has an incentive to find new tiles to step on, rather than standing on the same one, up to a penalty of 0.1, which is pretty severe if it's stood on the same tile for like 10 turns. This penalty decreases when you're near a door, because we want to give you time to figure out which button opens the door. But it's still, if you're standing by the door for too long, you still start to get burned. It gets uncomfortable. Then you have a base penalty. This is how we taught it to stay out of menus. Initially, the max penalty for this was like 10, which is immense. It's like a nuclear weapon on the statistics that the numbers that the model is crunching. And basically what it says is when you first go into a menu, no big deal, because we want you to gradually be able to figure out how to equip armor, switch weapons, and things like that. But every single turn you spend in the menu, the damage becomes exponentially larger until a penalty max of 0.1, which, like I said, used to be 10. So that you learn that you shouldn't just hang out in menus and bumble around. If you're going to be in a menu later, much, much later, you should know what you're doing. That's going to take a long time still. Then there are some terminal states where I just say, look, you've been like screwing around on this level forever and you're not encountering any enemies, or you've killed all the enemies, you haven't found the exit, you're not doing anything useful. Let's restart the scenario. These are not actually penalized anymore, but in the beginning I was penalizing them. Instead, what we're doing now is we're just saying, look, you're basically earning a penalty, for every turn where nothing good happens anyway. So we just reset you and we hope that gradually you learn the lesson. Yeah. And so we have a couple of thresholds. This one's fun. The peak drop threshold is basically if you, like whatever your highest score was that you've earned so far in this run, when you've dropped 250 points from that score, that's when I say stop and you restart the scenario. Right, and then we have the various bad and good commands. All right, now let's look at this next part. Here I can show you guys the agent actually running. That happens in this window here. And then here I have the window that it's running from. So this is like the main one. This is where I have it running from. Okay, so, oh my God, look at that. Look at that. It's actually on the stairs right now. Check it out. It's on the stairs. And now we're gonna get to see of this particular run, while it's running, if it's gonna find that spacebar. And holy crap, look, it found it. It found it. That was actually a level completion right there, just as we glanced at it. This has been running. This just runs here. I just look at it every once in a while. There's no cheating here. This just happened to happen, and it got it. Let's look at how often it has done that. So I have a relatively unsophisticated way of doing that. I just have this directory here where I see all the runs. I can copy and paste all of this and put it over here in a new file on the in my IDE. That is, my God, what's going on here? That is, wow. That is a new text file right there. And then I paste it in here, and you can see I'm searching here for this string already, underscore L2 underscore. That is basically the level. So every single run of these where I see that in the file name, those are the runs since my last video where it has reached level 2. And this whole list of the runs, this is the run since the last video, at which point I stopped it. And you can see here that it has, I don't know if you can see this very well, but it has reached level 2 92 times in the last 24 hours, almost 100 times. Now think about that. It took 5 days of, at first, very micromanagement training and then slightly less micromanagement training to get it to a point where it is reaching the end of the level and descending the stairs for the first time. And it has now taken 1 day for it to do almost 100 more passes of level 1. Another change that I've made since this initial day, this first setup, is that since yesterday, it's actually experiencing a different level 1 every time. Until yesterday, I had the seed of the level fixed at 123, which means it's going through the exact same level 1. The problem is that if you do that for too long, you can get what's called burn-in, right? Like the AI might actually remember a very specific path and a very specific sequence of events to get through level 1 because it's always encountering the same exact enemies. If it's on the same square and it shoots the same enemy in the same turn, it will hit always or miss always, and things like that will end up happening in this exact same sequence. And so since it reached the end of the level for the first time, it now gets a new randomly generated level 1, which means a potentially one of 15 different maps, slightly different enemy positions, slightly different chances on the first time you see the enemy, whether you're going to hit with your first shot or not. And it has to immediately, we want to make sure that we don't get it burned into, one very constant pattern. And we want to make sure it doesn't learn the wrong things. So it's always very important to make sure that you vary the things that you can or should be varying so that it doesn't get fixated on the wrong part of the screen, on the wrong detail while it's learning. But this is amazing progress. Clearing this 100 times in a day is amazing progress out of a few thousand runs. Now, one thing to keep in mind: why is it still mashing the spacebar for that long, as you've just seen? The reason it's mashing the spacebar for that long is because most of the time the spacebar is bad. I think I've mentioned that before, and it is taking, in order to get to that staircase those 100 times. It has played through, let me see how many it is again. It has played through 5,000 some odd run-throughs. So that means if you look at the number of turns, or the percentage of turns it has played that it has spent standing on those exit stairs, is extremely small, and it has to realize that it has to push this one button that it normally should never push, the space button, or that it rarely should push, and so that takes a long time. Now it actually probably knows to use the same button to open doors, which is kind of funny. But still, it's a very rare event that this is good, and so it's going to take a long time for that to converge. So what I'm doing now is nothing, right? For probably the next week, I'm not changing anything. I'm just going to see how often it clears level 1 and manages to hit the spacebar on the stairs to get to level 2, until I see that increase to about at least maybe every second or third run, maybe even 2 out of 3 runs, because level 1 on easy is very, very easy. I'm probably not going to change anything. Once that becomes more frequent, and once I see it stop mashing the button, I'm going to actually reduce some of those bonuses as well, because as I've mentioned before, large bonuses compared with these very small rewards and penalties actually just keep the model from converging. There's a factor here called the entropy loss, and the model is very fluid while it has an entropy loss above 2 or -2. Sorry, lower than -2. So it starts with a like -3.7 basically means like completely random button mashing. If it were below like above -1, so if it were like between -0.5 and -1, that would be a relatively certain model, knowing what it's doing and behaving in a fairly deliberate way. We're still at a point where there's a lot of randomness, there's a lot of exploration, there's going to be a fair amount of time that you see it bouncing in and out of menus. There's still a lot of chances for us to fix pathologies. What I do not have to worry about is that I'm now really waiting for higher order understanding to start to develop, for that third layer of neurons to start to kick in and pick stuff up. And I think that's going to take a lot more runs, right? So even if it might now get to a point where it's clearing level 1 like 2 out of 3 runs, and I can make level 1 a little bit more difficult, or I can consider letting it go to level 2, or I can just keep taking off training wheels, like reducing the magnets. That could all help it get better at making its own decisions and not following these micro incentives. And as long as it starts to get an idea, and this entire time, mind you, its understanding of the visual information that has in front of it and how it relates to the game state and how it relates to its own progress is also crystallizing, is improving. Since I have stopped giving it giant bonuses and giant penalties for camping on squares and for reloading its weapon and for landing shots, and since I've now made these things, these were all like double-digit numbers at one point, and now they're like single-digit numbers, and now I'm seeing the model training converge. It's gone down from like the entropy losses come from -2.9 down towards like -2.2. There's still a lot of learning happening. There's a lot of room for it to figure out how to equip a weapon from the menu. Even though menus are kind of bad, there's a lot of room for it to figure out how to equip armor. There's a lot of room for it to eventually maybe even learn that you take less damage if you're wearing something, stuff like that. So yeah, this is something that I'm gonna be having fun with. And yeah, the next video might be in a week, because now the work week starts again. I also won't do much. I'll just like keep an eye on it. Like I said, if it gets to a point where it's clearing the level very reliably or fairly reliably, and if I see the entropy loss come closer to 0 or come within or approach like -1, I'll probably start changing things up again just to keep the learning very fluid. But I gotta say, I'm very impressed at how much progress we've even made. Like, I wasn't even sure if this would get past button mashing in a week. So I'm very impressed that with some creativity and thinking about how you can reward it and stuff, you can really get it to start to engage with the game fairly quickly here. We're seeing relatively consistent success, and I'm going to be very interested in this and happy to give you an update like in a week and see how this converged, how often it started beating the level, what I've done since then. And until then, yeah, I hope you enjoyed it, and I hope you enjoy the rest of your day. See you guys later.